Welcome to Malware Analysis with Python. I am Professor Glass, and today we're going to be going over a recent zloader campaign using malicious Excel documents that contain old school v4 macros. Much of this analysis is based on the work of Didier Stevens and some of the analysis that he did on a similar sample about a month ago. So big shout out to Didier. Thank you. All hail Didier. All right, jumping in here. So I use Jupyter notebooks for my analysis because it's a great way for me to provide documentation and functional Python in kind of the same spot. So one thing I do at the top of my notebooks is I just give a hash of what sample I'm looking at. Helps me keep track of when I got these results, they were based on this particular sample. So here we're just importing hashlib and we're opening a file. This one is the v4 macro v1, and we're just importing that into a variable called file data. File data will be used throughout the rest of the analysis as a memory buffer that contains the data from the file. And then we're just going to give an MD5 hash and print that to screen. Easy peasy. All right, next we're going to import OLE or OLE VBA and import VBA parser. So this one's a little tricky. So I like to work with files in memory, import the file into memory and then have it to manipulate and slice and use whatever. But some tools are expecting files to be on disk. They're just kind of written that way. And this is one of those. So VBA parser expects the file to be written on disk, so it's asking for a file name. And later on down the road, it will throw an error if it doesn't have a file associated with it. So what I do is I just create untitled.txt, and I use that as a file name, but it's really inconsequential. It's just a sort of a nuance with the tool. And so next we're going to check for the existence of any VBA macros or just macros in general, and give it a yay or nay on whether or not there's any there. And so here it's printing out VBA macros are found. So this is like straight from Didier's blog, but this is kind of a good start to like, does this document contain macros at all? All right, analyzing the macro. So VBA parser does support a keyword search that gives you the ability to do some initial triaging of the macro to see what characteristics you may find in it. This one is triggering on two specific keywords, auto open and exec. So auto open is associated with the macro triggering once the document is opened. And exec in all caps is used in the older school v4 macros, so that's something to look for as we dig deeper into the code. So to take a look at the code, I would typically use VBA parser's extract macros function to pull out the individual files inside of the VBA, but this is a different kind of object. It's a BIF object, which is a binary interchange file format, so totally old school. And so when I use this particular module, all of the output is it appears commented. It might be the way that the module is interpreting the individual records inside of the BIF object. So I'm not 100% confident on the output of this particular module, and that might be why Didier made a separate module just for those, and that's what I ended up using. So I pieced this together based on the OLE VBA inside of OLE tools. So I import OLE file, and then from OLE tools I import cbif, which is a very specific plugin. And then I take the file data and I cram it into an OLE file IO object. And then I take that object and I read the workbook stream into a variable called data. And I take the data stream and I feed that into the cbif plugin with the option of -X to extract the macro. And then I use the BIF plugin analyze function to give me the underlying macro, and it produces that in a Python list. So I'm going to merge all that in with a join statement, and so I'm just joining that with new lines so that I can read the actual data. And when I thumbed through it, I saw a lot of these formula. Row 1, column 1, and then it references an integer, and then it references a char. So I'm kind of thinking there's some sort of char code going on here. So I want to pull out all of these lines in order to get like the totality of what these actually mean, if there's any more of them and what they are. So to do that, I use, yeah, here's an example of them. There's a bunch of these. To do that, I use regular expressions. So here I'm just going to import the regular expression module and then give it a formula. And the formula looks for, capital R with any numbers behind it and capital C with any numbers behind it. This is probably a little too specific of a regular expression, but I didn't want to be terribly greedy at this point. I didn't know what I was looking for. And then, so we can kind of see we got 61, 73, 73, 73, 67. And we can see how it's getting stored on the inside of the object in terms of how the formula is being compiled when the macro runs. So it's putting these values in these particular cells. So what I want to do is extract those numbers here, these char codes, and then convert them from decimal to their ASCII equivalent. So to do that, we're going to use a capture group. So here I have pretty much the same signature from before, but I'm putting parentheses around this digit here, and it will, this time when I do find all, I'm going to do a, it just gives me what was included in the capture group, so I just get those numbers, and that helps me out quite a bit. All right, so next I want to convert from char code and then join it all together. And here is the code for that, and I'm using a list comprehension here. But it does make quite a mess. But down here, there is legible code. So there's something that's working and there's something that's not. And I'm not, at this point in the analysis, I'm not sure what that was. I did want to give a, yeah, so what is this mess? So this is the characters being deobfuscated correctly, but they're being presented in the wrong order. And it's based on like how the code is written in the macro and how what order I'm deobfuscating the char codes. So we need to order the characters by column instead of their appearance in the code, which is a pretty easy fix. I did want to quick note about Python list comprehensions, because I struggle with those when I was learning Python. It's this is how I would typically write it, where you start with an output variable and then you loop through a list, and then you perform an action, and then you add the output to a specific to your output variable, and then you print that. Whereas the code down here performs the same function. It's more of a one-liner, but it's a little less intuitive. If you haven't really gotten into writing those, this is what that's about. So list comprehensions. All right. So to loop based on the column number, what we're going to do is mix it up a little bit, and instead of using a flat regular expression looking for any number, I'm going to loop through a range. So for I in range 0 through 100, I just picked a large number. What we're going to do is make a new signature every time and look for any row but column 0 and then column 1, and then but we're still going to grab this integer here and deobfuscate using that list comprehension and then print the string. So the result is deobfuscated macro. And this is really cool. It's like a trip back in time. It's a very basic language that I haven't worked with a whole lot, if I'm being honest. I think this came out in like 92 or something like that. So yeah. So let's go through each of the lines and kind of break them down. So the v4 macro language uses get.workspace and then some sort of integer that is a way to produce environment variables. So 13 is the available width of the workspace, 14 is the available height, 19 is whether or not a mouse is present, 42 is whether or not it's capable of playing sounds. And then getSpace1, which actually seems a bit more relevant, is the environment that Excel is running in, and this is checking to see if it's running on a Windows machine before it runs the rest of the code. All right, moving on. All right, so the next part pulls, it calls URLmons URL download to file, and it references a very specific C2 address, and then it downloads it to a C users public and then an HTML file. It will throw an alert, which is designed to give the user that sense of like, oh, why is this closing? All right, well, there was an alert, and largely it will be ignored as if the document didn't do anything. The workbook cannot be opened or repaired by Microsoft Excel because it's too corrupt. Then the last thing it does before it closes is it will take the file that was pulled down as an HTML file, and then it will run it with run DLL32, and it does give it the argument of DLL register server, which is fairly interesting and implies that it is a DLL. All right, so on to the second sample, because this one is kind of more interesting. This one happened a little bit, I want to say a week or so later. And so now we're analyzing this particular sample, and this is why I do the hashing before I get started. All right, so we skip through all the discovery, and we just go right straight to the heart of it. This is the same code we used last time, looping through the range to get these the macro code deobfuscated, and it looks like it works for the most part. Or did it? There are some missing characters, and let's take a kind of a look into that. So it looks like the if is missing an I, and the T is missing from get. Workspace is supposed to have an S in it. Yeah, it seems like there's every few characters there's just one's falling out. So let's take a look. All right, so looking at the second macro, it does appear that some of them are being concatenated. So every few lines are concatenated with an additional character. So some lines have 2 characters versus just one, and I think that's something that my previous regex isn't flexible enough to handle. So what we have to do is rewrite that. Yeah, these are where all the missing characters are. They're just concatenated. Uh, so the regex needs to be adjusted. There's a few ways to do this, and I'm sure that there's probably a much fancier, smarter regex way to do it. But the next slide contains my first take at it. Basically, I just do a two-step thing where I look for any formula string that contains the lines that I'm looking for. And then I loop through that string looking for any of these integer codes, and then I produce the macro code using the same join statements that I've been using. And now we can get a much better look at the macro code, and we see that the missing characters are now not missing. Okay, breaking down some of the more interesting lines from this second script. This uses reg.exe to export Excel security settings from the registry. So it's launching Windows System 32 reg export Hive key current user software Microsoft Office, and then it uses the Get Workspace 2, which gives the version of Office, and then Excel security, and it kicks it to a that same public folder with a one.reg file extension. So after that, it waits for 3 seconds, and that's probably to give the command time to finish. And then once it's done waiting, it'll open up the file, and it looks like it seeks to position 215, and then it reads 255 bytes, and then it closes the file, and then it deletes it. And then it searches through the data that it's parsed from the file for 0001. So when I did that on my machine, I got an inconsistent result from different versions of Windows. So I'm not 100% sure if this is the most effective way to pull down a Windows registry setting. But okay. Yeah, and so after that, it calls the same URL mod from before, and it downloads from a different C2 domain, and it saves to an HTML file. But this time, there's also a failover URL to go to, so two C2 domains for the price of one analysis. Yay! And that brings us to the end of our presentation. So a couple of things that were highlighted in here were some of the smaller stuff, how to open files, how to create an MD5 hash, and then kind of a brief introduction to DDA's OLE tools. Thanks again. And then how to do deobfuscation of macros using like capture groups in regular expressions. I'm also going to be putting a link down below, but I'll put them up on screen to all the references used to make this video. Thanks for watching.